And today I'm going to teach you about kinetic theory of gases. So actually what is meant by kinetic theory of gases? Kinetic theory of gases means it is actually the study of gases molecules. So we know that in a gas we have several molecules and each molecule, let us suppose that this is a container, this is a container, three-dimensional cubic container, and now and we know that every container or each and every object which is empty is actually not an empty, but it is filled by a gas. So let us suppose this container has a gas. That gas is moving in and around the container, and that gas, let us suppose that three-dimensional coordinates, that is x, this is z, and this is y, x, y, and z, and this point is our origin. Now first of all I will explain some of the assumption of kinetic theory of gases. The first assumption is that all molecules in a container all molecules in a container moves in different direction. This first assumption states that all molecules in a container moves in a different direction. It means that in a container, suppose it is a container, now it is filled by a gas. Now the molecules of gas moves in a different direction. Some of them moves along x-axis, some of them move along z-axis, and some of them moves along y-axis. So this is the first assumption. Now we'll go to second assumption of kinetic theory of gases. What is second assumption tell us is that the molecules in a container, which is moving in a different direction has different speed or velocity. So the second assumption, it states that the molecules in a container which is moving in a different direction, the molecules in a container, the gas which is filled in a container, and the molecules of the gas which is moving in a different direction along x, y, and z axis has different speed. Let us say that the molecules which is moving along x-axis has a speed u. The molecules which is moving along y-axis has a speed v, and similarly the molecules which is moving along z-axis has a speed omega. Now this speed. Now these are the main two. Among all the assumptions, these are the main two assumptions which to be known by each and everyone who is studying about kinetic theory of gases, and these are the two main assumptions through which we can derive the pressure of kinetic theory of gas actually. So now The main thing in kinetic theory of gases is the derivation of pressure of gas in the kinetic theory of gases. So main thing it is very necessary to derive the pressure of kinetic theory of gases, which is actually each and every question. This is a syllabus of BSc, and it is asked in each and every semester or BSc semester, which is on the fourth or second or whichever the kinetic theory of gases is considered. So now I will tell you about how to derive the pressure of kinetic theory of gases. So first of all, it's very simple. So look very carefully. So first of all, we'll derive the distance. Let us consider the distance between this from this origin. We'll derive from x-axis only. X-axis. So let us consider the distance. So now let us consider the length. Now we are actually finding the pressure along Px, then similarly Py, then similarly Pz. So let us consider the length from this origin to x-axis is L. It's L. So x is L. This L. Now what is the total length? Total length is equals to L minus L, because why we are considering L minus L, because once upon a time particles will move from x-axis, then will come, then molecules will again come back to its origin. So this is equal to L. Then similarly momentum is equals to mu minus, then again minus mu, this equals to 2mu. Now what is time? Time is equals to distance by, now time is equals to, since speed equals to distance by time. So what is time? Time is equals to distance into speed. Distance into speed. So here time t is equals to, what is distance? Distance is 12. And what is speed? Speed is u. So this is known as time. So after calculating all these things, so total momentum for unit time, that is second, will be equals to total momentum we have is 2mu. Then what is time? For time, that is into divided by time. So what is time? Time is equals to 2mu. So here I had made a simple mistakes in calculating the time. So this is not this. Here it is distance by speed. Here it is distance by speed. So if it comes out to be distance is 12, then speed u. 12 by u. So what is total momentum per unit time? That second is equals to 2mu divided by 12 divided by u. And this is equals to, or this is equals to 2 into cancel out, and v square by L is the total momentum for unit time into second, in second. So now guys, we know that force is actually this from second law of Newton's second law. Force is equals to mass into acceleration. So since we have velocity and it is divided by time, so we can write m u by t, and we know that u by t is acceleration. So this we can write, that is m u square by l is equals to force. Okay, m u square by l is equals to force. Now this force F is a force along its x-axis, on x-axis, that is f of x this is force. So f of x along, we are calculating the force along x-axis. So f of x is equals to summation over x equals to 1 to n, then m ux square divided by l is the force. Now after solving this, we are getting m u1 square by l plus m u2 square by l, then plus dot 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 plus n n m un square by l. So f of x is equals to m is common all the time, and m is also common, so we can write u1 square plus u2 square plus dot 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 plus un square. Okay, then this is a force along x-axis. So what is the pressure? Formula for pressure is equals to force by area. Since we are considering only x-axis, so only one part of the cube is considered. So area of cube, we know that area of square is equals to n square. If this is the length, then this is l square. So this becomes pressure equals to force by n square. So what we have here, putting that pressure along Tx is equals to force is all these things, so it is m by l cube, then this is u1 square plus u2 square plus dot 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 plus un square. Now this becomes the force, that is the pressure along x-axis of the molecules. So similarly, pressure along py axis can be written as n by l cube, v1 square plus v2 square plus dot 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 plus vn square. This is pressure along y-axis, and from z-axis it can be written as pressure along z-axis is equals to m by l cube omega 1 square plus omega 2 square plus dot 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 plus omega n square. So now we have got the pressure along px, pressure along py, and pressure along pz, that is x, y, z. So we know that pressure is equals to px equals to py equals to pz. So we can write this as, there is three terms of pressure, three coordinates. So we can write p equals to 1 by 3 and it is again Px plus Py plus Pz. This is actually the working formula. This is actually the working formula. Now I'll erase this all and write. Now pressure is equals to 1 by 3 of Px, Py and Pz. So if we see on Px, Py, Pz, n by n cube is all common in all the three pressure along x, y and z. So we can write n by l cube as a common factor, and then u1 square plus u2 square plus u3 u2 square plus dot 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 plus u1 square, then again v1 square plus v2 square plus dot 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 vn square, then again plus omega 1 square plus omega 2 square plus dot 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 plus omega n square. You can write this now. P is equals to 1 by 3 m by l cube. So actually rearranging this, u1 square plus v1 square plus dot dot plus then again plus dot 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 v1 square plus omega 1 square, then again plus u2 square plus v2 square plus omega 2 square plus then this is dot 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 plus un square plus vn square plus omega n whole square. Okay, so now P is equals to 1 by 3 as it is n l by cube. So this term could be written as on the bracket could be written c n minus n c bar square is equals to c1 square plus c2 square plus c3 square plus dot dot dot, then it is b, then it is c square and then it is divided by n. Okay, that could be written. So what we have here is n c minus 2. Now P is equals to 1 upon 3 m by, what is the volume of the volume of the cube? Volume of the cube is L cube. Volume of the cube is L cube. So we can write L cube as V, then here n minus 2, c bar 2. So again pressure can be written as 1 by 3. N by V is a density because density is mass by volume. So M by V is a density. So mass by V is rho. Then here is N, then density is. So this is the required equation of pressure of kinetic theory of gases. In kinetic theory of gases, this is the required equation of pressure of gas in a kinetic theory of gases. So hope this video will be like. Once if you like this video, then and if you understand this video, then please like my channel, subscribe my channel and share with your friends, because it will help you more to grow upgrade. So at the last, please comment me if you don't understand anything else, then I will again try to expand it in my own thinking.